The first thing in the integral part is we need to understand what do we mean by application of integrals. So here in this chapter, we are using the concept of integration. We're using the integration part, not the concept. We're using the integration to find the area under the graph. Okay, so the area under the graph, whenever we talk about, is basically when we say we have integration y dx. So basically we are saying that we have a graph or a curve y is, okay, and what we are doing, we are integrating it. Now let's say when we are telling a limit a to b, we are integrating it from a to b, and the area of this graph y is equal to fx with the x-axis, under the x-axis. So that's why the name of the chapter is also like area under the curve or area under the graph. Okay, now area under the curve is basically denoted by a to b function fx dx. Now, so what we are doing is, now I could have taken in y-axis also and x-axis also. A lot of students, they have a difficulty in understanding what is the area under x-axis or y-axis, and they get complicated, they get confused when they see a question where we have a graph something like this mixed with like this. So which part of the graph to take it, which area they're referring to and all that. Okay, so don't worry, understand, it's very simple. Okay, so when we are talking about this area, let's say we have this graph. Okay, and I'm telling that I want to find the area under the graph with x-axis. Okay, so basically when I say integration of y is equal to fx dx, the moment I use this dx, it means I'm using the x-axis, and the limits I'll be substituting from for the x-axis. So from where I'm starting, from the point A to in x-axis to which point? B. So A to B, this one, that's it. So A is equal to, area is equal to integration of A to B f of x dx, and that means that limits will be of x-axis, and we are finding the area of the graph with the x-axis, along the x-axis. Clear? Now there is also area of the graph along y-axis. So we'll see how we do it. Now we have taken a curve like this. Now this time we want to find the area of this curve along y. So this is my y-axis, this is my x. I want to find along the y. So what I'll do, again, what I told, since I'm finding along the y, the limits will be what? Along the y. So let's say I'm finding it from A to B, let's say. So A to B, what I'll do, I want to find, now this curve is basically x is equal to f of y, correct? So what I'll do, x dy, correct? Done, that's it. So this dy shows that it is along y-axis. So you understood, if I want to find the area along x-axis, I'll take the limits of x-axis and it will be integration of y dx. So integration y dx means area along x. And the moment I do along y direction, it is nothing but, or along y axis, it is integration x dy. Okay, so this is very important. Now sometimes you'll see, instead of being on the top, it is sometimes below, okay, in the fourth quadrant. Then what are you gonna do, sir? Okay, in that case scenario, basically nothing is that area by default we mean it is positive quantity. So what we'll do, we'll just take a mod, and whatever the negative quantity will come, we'll just mod it up. Okay, that's it. Coming to the next part, whenever we have area of two figures there which are joining each other or cutting each other or intersecting each other, in that case we want to find the common area or the area between the two curves. So let's say we have a curve y is equal to fx and we have a curve y is equal to gx. Okay, student, understand first. See, this all thing what I'm trying to explain here is for your understanding purpose, so that if they're changing the problems a bit here and there, you will be able to apply the understanding and you can figure out the answer. Now, most of the questions in this chapter will be very simple and will be able to solve by using two formula of integration that I'll put it in the last section. Okay, 2 to max 3, that's it. And in a lot of places we don't have to integrate also, and we'll be able to find the answer. Okay, now everything whatever is read it, the short tricks, the standard results and everything I have given, but along with that I'm telling you to understand the concept. In case if they try to change it, we can't go and sit and start crying, correct? in the exam center, let's say they gave you a scenario where they have just changed a bit and you don't understood, you don't understand the way it was formed, the way the area works, okay, the way the definition is there. So what will happen? You won't be able to improvise on the situation. And you'll remember, sir told me only for this is the formula, that's it, done. And you'll end up not being able to solve the problem, while the problem is very simple. If you had known the concept a bit more properly, you would have got the answer. Okay, so understanding is very important along with that. So once, while you are writing, while you are watching this video, take a pen and a paper and write down each and everything. Okay, students, a lot of students, they take it very lightly. They just watch it like a normal video, just watching it for the fun and entertainment. See, while doing an online class, what you have to do is you have to take a pen and a paper or a notebook or your formula notebook and write down each data. So the moment you write, you start questioning, okay, why? So either you will come up with two of the answers. Either this is a KCT, this part is already derived somewhere, but I don't need to know the derivation as of now, and I just need to know the formula and how to apply the formula. Second part is, if they're doing a change in the question, if they're doing a change in the problem like this way, how I need to modify so that I get an answer. That's it. Now let's say we have two curves, y is equal to the first curve, y is equal to fx, and the other curve, y is equal to gx. I want to find the area, this part. So how will I do? So first, whenever I'm telling I want to find the area of y is equal to fx from a to b, so basically I'm referring this whole area, correct? This one part and this two part. Now the second part, the moment I'm saying I'm finding the area, of y dx and y of gx dx, okay, from a to b. So basically I'm getting this area. So you can understand, if I subtract the whole big one from this small one, I'll get this middle area, correct? Yes or no? So area, this one gives me 1, and let's name it 2. So this is giving me 1 and 2, and this one is just giving me 2. So if I subtract 1 by this 2, 2 will be cancelled and I'll get the area 1. So that's why area is equal to integration of a to b fx dx minus gx dx. Okay, so that is equal to the upper curve, the what we have, minus the lower curve. That's it. Now a few important formulas which we will be teaching you in depth with the derivations in the first PUC chapter. So don't worry about that. So but just go through the formula, write it down. So very important. Y is equal to mx plus c, any line can be written, and this m is the slope of the line and c is the intercept. What is this? This is basically what? Y-intercept. The moment you put in this equation x equal to 0, you will get where the graph or the line is cutting the x-axis. Okay, so that is the y-intercept. That's it. Y is equal to mx, no intercept because it is passing through the origin. When I put x equal to 0, I'll get y is equal to 0, correct? Now intercept form, it is cutting x-axis and y-axis at what? 2 points. One is a comma 0 and the other is 0 comma b. So you can put this x by a plus y by b is equal to 1. Simple equation. Okay, I've given you each and every formula because I know when we were also students, so we used to forget a lot of things. When we are trying to put a lot of stuff, we'll tend to forget a lot of stuff also. So I've given each and everything in one place so that you can write and you can revise. So before, one day before or 1 week before the exam, you don't have to search like where is this formula, where is that formula. Every formula will be there. Whenever you know you have 2 points, x1 y1 and x2 y2, what is the equation of the line? Y minus, you just take a general point here, x comma y, and try to find the slope between these two and these two. So or you can find the slope between these two and these two. So y minus y1 by x minus x1 is equal to this slope m, and that is also equal to y2 minus y1 by x2 minus x1. Next, standard formula. First, very important for the circle. If the circle is passing through the origin, okay, then what is the equation? X square plus y square is equal to r square. Here what is that? The center is 0 comma 0 and the radius is r. That's simple. Now if the the circle center is not at 0 comma 0, at some point h comma k, and the radius is r, in that case this is the formula. X minus h whole square plus y minus k whole square is equal to r square. That's it. Now this is also the general equation of the circle. To find, this is the center, this is the radius. We won't be using much, but just so that you have each and every formula at one place, I have given you all the formula. Okay. Now parabola, very important. A lot of students, they do mistakes in writing this equation, general equation of the parabola. See, very important, whenever I write x square is equal to 4ay, it means, see, square is on x means two values of x, plus 2 minus 2, both are related to one value of y. Okay, so what you can do, just draw a line. So for two values of x, you can remember like this. For two values of x, you will get, let's say, one simple value of y. Okay, so it means whenever I have equation x square is equal to 4ay, it will be upward parabola and it will be symmetrical about y-axis. Means if I draw a line along y, it will be able to cut the graph into two equal parts. Correct? Now, if it is positive, it will be upward parabola. If it is negative, it will be downward parabola. That's it. Clear? Now, the moment I have x square is equal to 4ay, it means it will be upward parabola like this. Okay? Clear? The moment, how to understand whether it will be along x-axis, what is the symmetry line? Symmetry line is, first in this case, it is the y-axis line. Now, if I draw a y-axis line, I'll be able to cut this whole, parabola into two equal half. If I try with x-axis, not possible. Okay. Now, in this case scenario, see, the symmetry line is x-axis. Okay. That's why we have y square is equal to 4ax. Clear? If it is y square, symmetry line is what, student? You can understand with symmetry line. Symmetry line is the line which is cutting into two equal half. It is x, opposite. Okay. And if it is x square, the symmetry line is what? Symmetry line is x-axis, sorry, y-axis. Okay. Now in this, y square is equal to 4x. If it is positive, we'll get what? Right hand side parabola. If negative, this left hand side parabola. Now the most important point that you need to understand here, okay, is in KCET you will be getting this equation, upward parabola or the right parabola. Okay. So these two equations are your most important thing. Okay. Now I've given you the ellipse. Ellipse again. So what happens? It has two focus, one and one here. I'm not going in details about the definition, what is say, and all that. I'm just giving you the equation of ellipse. X square by a square plus y square by b square is equal to 1. Now here you need to understand we have two kinds of ellipse. One is x-axis ellipse and the other is y-axis ellipse. Okay. X-axis here, in order to understand what is an x-axis ellipse, now you'll see that this x is the denominator of x square, a square will always be bigger than b square. So when the denominator of x is bigger than the denominator of y square, then in that case scenario you can say it is a x-axis ellipse. You can see by seeing the diagram of this ellipse also, the major axis, the bigger axis is what? The x-axis part, correct? And the minor, this is a smaller one, minor. Okay, so the major is 2a and that is bigger. So that's why in this equation x square by a square plus y square by b square is equal to 1. This denominator, the denominator of x square is bigger. So you can understand by the denominator, if the denominator of x square is bigger, it is x-axis. If the denominator of y square is bigger, it is y-axis. Clear? Because a lot of questions they'll give you on major axis and minor axis. We'll go a bit more detail in the chapter, conic sections, and this since it is removed, so we're just going on the top so that every formula is there with you and you're able to understand and you're able to solve it. Okay. Now area of this ellipse, very important, pi AB. Okay. So sometimes we'll be using half of this. Okay, 1/4 of this or half of this. So if I know the whole area of the ellipse is pi AB, what will be 1/4? 1/4 of AB, pi AB. Correct. So you'll be using, if somebody is cutting it into half parts, so we already know the ellipse area, 1/4 quadrant of the ellipse. Okay, and just if I can find this area of the triangle, we can use it. So a lot of different questions will show you with the question how to solve it in less than 30 seconds. So don't worry about that. Okay. Now this is the y-axis ellipse. See, the major axis is what lies on y-axis. Okay, so this is the bigger one. So the denominator b square is greater than a square, and directly you can say it is bigger. Okay, I've given you everything in this, don't worry. Now I've given you the formula separately, length of lattice rectum. Now first understand what is lattice rectum. A lot of students, they have difficulty. Let's say this is my parabola, this is my focus, and if I am drawing a line perpendicular to the focus, okay, like this, with this axis, y-axis, this line which is touching here and here, this length is known as the length of the lattice rectum. That's it. Okay, so I've given you the diagram, this length passing through the focus, okay, and touching the circumference of the parabola is known as the focal length, lattice rectum. So formula is same. In all this, it is 4a. Directly you can write it. No change, no difference. And for the ellipse case, it is 2b square by a. This is, we have two lattice rectum here. Correct? 2a square by b for the other case. Okay. Then I have given for hyperbola also, though we don't get much. Just for the formula sake, I have given you everything. Now standard results, very important. A lot of channels, a lot of places you will see, a lot of books what you'll see, they'll have given us a short trick and all that. These are nothing but the exercise questions or like example questions of exemplar, NCERT and all that. And we have just picked it up so that you can use it if they come it directly. And KCET, a lot of times they give it directly also. So you will be in a much beneficial position, okay, if you know these values, but you need to know it exactly the way it is. Okay, now area of the region bounded by, we have a curve y square is equal to 4x. Just now I told y square means what? Y square means what? It is this one. The line of symmetry lies on the x-axis. Okay, for two values of y, one value of x. Okay, very simple. Again, x square is equal to 4by. For one value of y, we get two values of x. Now we need to know this part, correct? So we can subtract and get it also. No problem in that. Okay, we can subtract and get it. We already know. See, this part is for this one. Let's say this one and this is 2. Okay, so what you can do, integration of area under 2 minus area under 1. Okay, and we can get the answer, but directly you can use this formula. Area is equal to 16 by 3 AB. So you need to understand what is AB properly and you need to write. Okay, so don't do mistake in that. Okay, you have to bring first the equation in this form, then only you can apply this formula. So you need to understand that. A lot of students, without understanding any graph, whatever way they have given, directly they write 16 by 3 AB. That is wrong. Okay, next, area of the region bounded by y square is equal to 4x and y is equal to mx. Y is equal to mx is a straight line passing through the origin, and y square is equal to 4x is a parabola equation, right hand side. Okay, so again the area formula is 8a square by 3m cube. That's it. Again, between an ellipse and a line, see what we can do. 1/4, this is what I told you, 1/4 of ellipse, 1 by 4 pi ab, minus this is what, area of a triangle, half ab. That is the formula. Okay, so you can do it like that also. It is very simple. This formula, again, when you have a parabola, y is equal to ax square and y is equal to mx, you can use this formula. So you can memorize these results, but try to memorize along with the diagram so that you understand, okay, this is exactly this equation. If this comes, then I will be able to apply this. Okay, now coming to the next part, we have a circle and we have a parabola and we want to find this region. Okay, so directly we can do, and this is for the parabola, y square is equal to ax, and the circle equation x square plus y square is equal to what, 2ax we have. So directly we can apply a square is equal to pi by 4 minus 2 by 3. Okay, directly we can use it. Is it a PYQ question also, so don't worry. Mostly we'll be using this and this formula, and everything will be converting into this and this form, and we'll be able to solve it. But the whole formula as a whole is important. If you want to score 50 plus, don't take any chances. Okay, and work hard and do everything what I'm giving. I have not skipped any of the reduced portions also. A lot of students have commented in the comment section, so this is from the reduced portion. If KCET is giving you any question from the reduced part, we can't later cry or say anything. If it is not coming, well and good, but anyway maths is always linked, so do everything if you want to score 50 plus. If somebody has a target of just 30, you can skip it, no problem. But if somebody wants to score 50 plus, be smart, do everything so that you don't have a problem in that. Okay, so that's all for this. Everything is given in detailed manner. Okay, and if you have any doubt, put it in the WhatsApp. Its link is given. You can join the Telegram channel. You can put it up there. You can put it in the comment section, and you can also ping us in the website onlinesamclasses.in. Okay, that's it.